We can use the principle of square roots to solve equations like the ones shown here. Since we have something squared equal to a number, taking the square root of that squared quantity results in this case, an x minus 5 equal to the square root of 9, which is a positive 3, or is the opposite, a negative 3. The only thing left then is to solve for the variable by adding a 5 to both sides, resulting in x equal 8, and adding 5 here, x equal to 2, are two solutions to this quadratic equation. Likewise, we'll use the principle of square roots on this other equation, taking the square root of each side. The square root of something squared is that quantity. It is equal to positive square root of 7, or the opposite, a negative square root of 7. Again, solving for the variable, we'll subtract 2 from each side, which gives us the following solutions. T is equal to negative 2 plus square root of 7, or t is equal to negative 2 minus square root of 7. We can also use the principle of square roots here, although it doesn't look like the same form as the problems on the previous screen. Since this is a square of a binomial, in other words, a perfect square trinomial, we can factor. Putting it in exponential form now has it in the form of the quadratic equation that we saw on the previous slide. We can apply the principle of square roots, taking the square root of each side, to give us a simplification of this equation. X plus 4 is equal to the positive square root of 49 and the negative square root of 49, illustrated here as x plus 4 equal to the positive 7 or negative 7. Separating this, we have the two variations for the solution here, and solving for the variable, we'll subtract 4 from each side to give us solutions of x equal 3 or x equal negative 1. Of course, you'd want to plug these solutions in to verify that these do, in fact, give us a true statement. Here's another example of a quadratic equation that if we factor the trinomial on the left, we find that this is a square of a binomial. It's a perfect square trinomial. Putting it in exponential form is shown here. We now can use the principle of square roots, taking the square root of each side. The square root of something squared is that quantity, and using the principle of square roots, we will have the positive square root of 10 and the negative square root of 10. Separating these into the two possible solutions are shown here on the right, and solving for x then we'll subtract a 3 from each side to give us our final solutions of negative 3 plus square root of 10, or x is equal to negative 3 minus square root of 10.